Hello, everyone, and welcome to another edition of Code Remix Weekly. We are your usual hosts, Tim and Sam. I'm Sam, and that's Tim. How you doing, Tim?
Hi, just fine. How are you?
Doing all right, doing all right. So this is, I understand, a rare period of stability for you, where you are actually in the country that you reside in, and not off to Germany or somewhere else to visit a conference or the like. How is it? How is it visiting the Netherlands every now and then?
It is. It's pretty good, I have to say. It's like it's a decent living room if you spend some time in there. It's actually
That's good. That's good. I understand you've been doing a lot of rock climbing. Is this mostly in a gym? Because it's not like the Netherlands has any like actual mountains for you to go climb on. So are we talking
I,
gym, or are
I
you
wish.
again
I
going to
wish.
another country for it?
No, this is all indoor, but it's a mixture of bouldering and top rope climbing.
Yeah,
But
yeah.
it's been a lot of fun. Alternating with different friend groups and somehow ending up climbing like 3, 4 times in 8 days. So
Nice.
my arms are suffering. Like
Yeah. Your forearms in particular. Like, can you grip anything right now? Like,
it's right now it's okay, but like I was at the gym yesterday and we're doing like the real long routes, and halfway through you kind of just have to surprise your climbing partner that they get to catch you as you fall down, which is I don't know.
well, you want to test to make sure they're paying attention. You don't want them getting
No,
complacent
no,
while they're belaying you. So making sure they're awake every now and then is sensible, probably.
no. It's like I always like you do these buddy checks where before you go up and you think
Hmm.
those are fine, but it's really when you're like 15 meters, 20 meters up, and you start to doubt whether you did the check and whether you can really let go. That's it's not a good feeling, but so far I
Yeah, yeah.
survived.
I feel like a decent part of rock climbing is fear management, avoiding panicking in the moment, as even as your muscles are failing and you can't remember if you did the checks. Do you have a strategy or a mantra for maintaining your focus and concentration in those moments of strife? Like when you're hanging
Um,
off the wall and you don't have that good grip and it's tired and you can't remember if you did the check. How do you avoid just screaming and falling, or do you just scream and fall?
no, I'm usually pretty reserved. It's just like you think it should be fine, and then you find out pretty soon, and otherwise it's not your problem. So yeah, it's gonna be fine either way. Then
Hmm.
yeah,
Hmm.
I think in the climbing world you also have the concept of the type 2 fun, which is something that is only fun in hindsight, and sometimes not even then. So that's yeah, uh, something to look forward to in my future travels.
Something that's only fun in hindsight. Yeah, those we'll laugh about it someday moments.
Yeah, yeah. Or you just climb something and you're not sure you're gonna survive, but you made it through. Like I
Yeah, retroactively recontextualize it as fun after you've achieved the triumph, or at least the relief of having avoided death.
I recall one of my hiking trips in Patagonia where I saw black and white for 15 minutes. That was very much on the scale of type 2, type 3 fun.
But you mean you saw black and white? You're talking about like what do you mean there?
Yeah,
Saw
it's like
like you're like about to pass out, like faint?
yeah, the body has a way of conserving energy by only allowing you to see black and white when you wake up camping in the snow and you're absolutely miserable. And it's like
It's like we don't have any energy to spare on color vision. Okay, I
yeah.
might my the life I have lived has maybe been a little bit too soft for black and white vision, but good to
Yeah,
know
but
I have that phenomena waiting for me in an extreme
mhm.
circumstance. And of course, Kevin points out that there's the type 3 fun where it's not fun in the moment nor in hindsight, which
And then yeah, no, that's Kevin. That's it was actually I think we've discussed doing the same hike, but it's just I was a bit earlier in the season than Kevin was, so it's small
so this
differences.
is so this is a phenomenon, Kevin, you've experienced, or you've avoided experiencing, which honestly sounds a bit smarter. Yeah, leave a comment telling us your most dangerous nature expedition. What are our announcements for the week, Tim?
We have just a couple, so I'll bring them up. So one is that we have a new blog going from tech debt to tech stack liquidity, where amusingly there's some visuals to go with it on maybe the correlations between geology and maybe diving into your older tech stack. So if you want to hear how those two relate well, then go to the blog that we have here at Modern. I'll share the link in the chat right now. And also new is that we have one of our trusted customers came out with a kind of their experience of adopting Modern and OpenRewrite. And that's been a really fun read to see how they've been able to achieve a lot more than they were planning to initially, and just a great success story for all involved. So that's really fun to see. Then also new is that we have put out a customer newsletter. So this, we won't go into too much detail because you have to be a customer to actually read up on it. But we do share these from time to time, where everything that we've worked on over the past couple of months, as well as the things that we're looking forward to in the next couple of months. So if you're curious about that, maybe become a customer, get the newsletter, subscribe, and then you'll be able to look there. Or freeze frame what I just scrolled through. So I hope you'll get involved there.
This is what our customers come to us for, the good newsletter.
And then also new is that we finalized the planning for January and even into February, I believe, for the new trainings. As you know, we do these trainings every month. We'll do typically we do like an intro and an advanced course. But for January and February, we're going to mix things up a bit because we know there's a lot of interest in upgrading to Spring Boot 4. So we're going to do a dedicated session on that one. And we've also had a lot of interest in using AI to author your recipes. So we're also going to do a deep dive on that specifically. So if you're interested in any of those topics, or you want to do next week's advanced training, then go to the training hub that we have and you can sign up for whichever strikes your fancy there. And then lastly, our friends at JetBrains, they have of course put out an IntelliJ IDE 2025.3. I've been using it for 2-3 days now, and it works really well. So I would recommend folks upgrade. And of course, in tandem with that, we've released a new version of the Modern IntelliJ plugin. So if you're using that one and you want to upgrade to 2023.5, then get the latest 0.9.8 as well to go along with it. Otherwise, you won't see your familiar Modern logo in the top right corner. So that's all the updates that I have for this week.
Very cool. Well, that brings us to our main topic for the week, because I neglected to collect my favorite memes. We'll have to bring that segment back. I was thinking I'd also supplement it with my favorite programming related articles that I've read this week. So yeah, if you have a favorite programming meme or an article, I'm particularly partial to stories of debugging where an inscrutable problem came up, and through great rigor and persistence, the problem was resolved. So if you have either a funny programming meme or a good debugging story, be sure to hit us with that in the comments so I can check it out and maybe feature it on next week's show. But for this week, I thought we would talk about data flow analysis and taint tracking, which are some advanced concepts in static analysis, which OpenRewrite has some capabilities for, and particularly it's going to show you a peel back the curtain a little bit on one of our proprietary recipe modules, rewrite program analysis. So this is not normally open source, as we just don't open source this one, but I figured I'd show you some of it so you can get a sense of what the capabilities are in the framework, and think about some of the recipes that you could create with this, or that you might want to take advantage of that already exist. So the gist of data flow and program analysis and taint tracking is that these are techniques for static analysis to keep track of how information or state flows through a program, so that you can analyze or ask and answer questions about consequences. About and by consequences I mean, there's lots of, particularly in the security space, problems or scenarios where a sequence of things has to happen just so in order for there to be a security problem of some kind, right? Like it's not a problem to call, to configure a cryptographic cipher unless, it was untrusted user data that's telling it which cipher to configure, or, maybe more commonly than that, untested or unrefined user input being put directly into a SQL query, right? It's not a problem to issue a SQL query against your database. It is a problem if data coming directly from a user is going directly in there without some intermediate step to clean it. So when you have a scenario where it's not enough to just visit a single method invocation or a single variable declaration, but you need to ask and answer questions about what came before or what comes after this method or variable declaration, then data flow analysis can be a powerful technique for answering those questions and making more advanced recipes. So I will go ahead and share my screen. Cool. And tell me, Tim, if I need to make any of the text bigger on here. But I thought we
No,
would
it's
look
fine.
at this find dead stores recipe, as this is a pretty direct example of exactly the kinds of things we're talking about. It's not too hard to understand. A dead store is just any place in your program where you write a piece of data into a variable or into memory somewhere, and then you don't read it anywhere else, right? A pointless write, a store of some data
Mhm.
that is dead because nothing ever accesses it, so something that could like safely be removed. So this has so we can look at the test cases in here to get some ideas about some of these things, right? So just a method that does some assignments to variables but doesn't do anything with the data in those variables. These are, all dead stores because this information is never read. In another example, X isn't a dead store because it goes into Y, but Y is a dead store because nothing ever actually uses Y. Uh, Similarly, the whether something is or is not, might be true only in one branch, but not on the other side of a branch. And so, part of data flow is taking control flow into account, so that you could say that like X is a dead store on this code path, but not on this code path. So you could only potentially delete it from one, but you could like move it into the only code path where it is used, for example. And so not a dead store in a loop because you're using it in the next iteration of the loop. Although you could make an argument here about some never being read for anything else, but just in general, you
Mhm.
wouldn't call that a dead store. Okay, so as you're looking at these, if you're familiar with recipe authoring, you're like, okay, well, I want to look at variable declarations or assignment statements to begin with to begin with this, but that isn't enough to totally answer the question: is one of these things a dead store or not? Because it's all about what happens before the assignment, what happens after the assignment, where does this data go, how is it used? Well, sorry, not before the assignment, very, very much after the assignment. Does anything use this data post assignment? So if we go and look at the implementation for this recipe, we see that it starts off with a very typical recipe setup. We're just returning a typical Java visitor. But inside that Java visitor, we're taking advantage of some of these control flow capabilities, like this control flow support.analyze method, which takes in a cursor to an element of relevance and an analysis, which is, if we go and look at the implementation of this guy, a class which implements this control flow analysis type, which we can look at this real quick. And a control flow analysis is, more or less a functional interface, which just has an analyze method that's going to take in a cursor and a control flow graph and return some user specified piece of data. So in the case of dead store analysis, we're going to return a set of J, which is, we're going to keep track of the set of all the dead stores, all the stores that don't have the data that's written into them read afterwards. And the so in this analyze method that is overriding from control flow analysis, it is able to use the control flow graph to collect assignments. Where if we check in here, we can see from this control flow graph, you can call various methods like get all the blocks. So like all of the things that are like feeding that are feeding into this, and able to get the list of relevant statements out of these blocks and look through them for assignments and for variable declarations that are relevant. So you can kind of just like build up, here's all the assignments and variable declarations that are like flowing into the current one we're interested in. And so that we'll have that information for later on in the analysis in order to make the determinations. So, here are all of the assignments that are relevant, that are in scope in the place where the cursor was pointing to, where we started this analyze method. And then we can look at this is dead store method, where it's going to check and see if the variable is used after the assignment. And so this is again where the control flow graph is going to be passed into this check successors method to see of statements subsequent to this particular assignment, do we see a read of the data that has been written in here? And so inside of here is where you can use this get successors method on the control flow graph to find the blocks following the current thing, right? What happens after the thing I'm looking at? And if nothing comes after it, well, then it's definitely dead, right? If nothing comes after them, there's no chance for the data that was written to be read and acted upon. So we're done here. And then if there are some actual successors, then we're going to go down and look through each of the paths and find a place where the variable is either in used, or we don't find anything and determine it to be dead. But let's look at this check path method, kind of see how that works. Looks like we have an unused variable right here that the IDE is highlighting as a dead block. But yeah, so let's see. So in here, we are checking if we're just keeping track is the same block might end up appearing multiple times in this analysis. So just a quick, we already looked at this one. If so, skip it. And then, going through each of the statements in the block and checking. I'm curious about this is variable used in. Is this going to visit? Find variables. Okay, good. So this does declare a visitor to go down inside of it. I was just concerned that sometimes there's a basic mistake. Often when you see something like this in a recipe, and this is a little bit more general piece of advice about OpenRewrite than it is specific to data flow analysis or taint tracking. Often in OpenRewrite, if I see someone iterating over a list of statements like this, I'm like, you might be making a mistake here because you might need a visitor to do that correctly, right? Because if you have a very flat list of statements, then you can iterate over it as normal. But and get to everything, but often statements are nested inside of other statements. So if you're interested in like a return and you're iterating over everything in the block and not visiting everything inside it, you might not see this return. Like you'd see the if, you're like, I'm looking for returns, not ifs. So you wouldn't find the thing you're looking for. So when so I'm glad to see in the implementation of this that is variable used in and is variable defined in are applying a visitor to each of those statements, which is, the only way to find for sure that, a particular identifier appears in that statement as you're visiting not just the statement itself, but all of the sub-statements that it is composed of. Let's see. So a little bit of a tangent there. So we're going through each statement and checking, hey, is the variable of relevance used or assigned to something else in here? And keeping track of down that particular code path, what is the result of interest here? And do we get to the end without finding anything, or do we actually find a place where it's used? And if it is, we don't need to keep looking down this path because we've already kind of made our determination here. So this is all a bit complicated, but it's possible, right? A well-designed API should make simple things easy and complicated things possible. And this is verging into the making complicated things possible territory. I sometimes think that our representation of code, the LST, is too syntax oriented. Like it makes making semantic questions or asking and answering semantic questions maybe more difficult than it needs to be. But I also don't have a really clear idea about what a more semantic representation of code might look like. So yeah, I don't know,
Yeah,
Tim. Anything I missed in there? You think?
no, I think that the LST indeed very much is the representation of these printable elements that we see in the
Yes.
source code. And I think that's particularly come up when it concerns things like annotations, which might have
Yes.
attributes, and they have different ways in which they may appear. It can be like a single string as an attribute, or an array of attributes, or assignments to specific fields. And all of those, repeatedly we see the question come up like, why isn't there on the annotation a method to just get the value of an attribute? And then we kind of have to come back to, well, it's pretty much by design. Those LT elements really are just the printable elements. And we did, of course, introduce the concept of traits to be able to abstract over various ways things might be represented. So that's what we typically now point folks towards. But I can understand the challenge sometimes when developing these types of use cases, that you really have to handle all the different variations of how things are represented.
Yeah. I've been thinking about traits a little bit, and and some of the challenges or shortcomings of using them in the framework. And sometimes I think the challenge I have is that right now traits are very oriented around a single cursor, right? Like you are passing in a trait is constructed from a single path within a single source file, but sometimes the trait or the attribute of relevance to a problem is something that crosses multiple files. It's like am I looking at a Java source file that is in a project that has a particular dependency on its class path? Am I looking at a source file that is using a variable that is defined in the same project or a different project, kind of thing? Is the parent POM for my POM in the current repository, or is it in a different repository? It might change how a dependency management recipe operates. So this is maybe getting on a little bit of a tangent for data flow and taint tracking analysis, but I have been thinking about how can multi-file traits be implemented in a way that would simplify some of these more complex scanning recipes we have, right? Like we made this push to simplify some of the dependency management recipes, and that has sometimes been difficult because there's just a lot of like cross-file, cross-repository questions, right? Like, what are the dependencies of this? If I want to make a change in this build file, well, this depends on these other modules in the same project. Like, do I need to go do something there? Anyway,
of course, we've been kind of skirting around the problem with like markers that are on the source file and shared between different source files, and it's kind of complicated at that point. So.
Oh, is that true? The shared between different source files markers? I mean, it's certainly true that like when we parse like that a Gradle project marker or a Java source set marker, are those the ones you're talking about? Or are you talking about a recipe that adds like a marker that is like the same instance in memory to multiple files so that like information can be shared between them?
Not between recipes, I believe. That well, I would have pretty much flagged as an automatic note. We're not going to do this. But no, as we do when parsing projects, we have some markers that end up on like shared between the source files. But of course, when you start to change them, then of course that gets lost with the immutability.
Yeah, I've been thinking that it's kind of, and again to go on another tangent about things I've been thinking about on OpenRewrite recently, is like one of the challenges that recipes have is that you start with an accurate model of all the metadata, all the type information, and what all the dependencies are, and as soon as recipes start making changes, how up to date or how correct that model is starts to depend on how thorough recipes are about updating it, right? Like if you have a recipe that goes and changes a very, let's say a method signature, that you go change that method signature, does that recipe also update all the type information that references that method signature for the rest of the project to have that new model? Sometimes it does, but sometimes maybe the recipe author didn't think about that or didn't run into that. And so I've been kind of thinking that like, yeah, maybe the LST elements themselves should definitely stay immutable, but maybe the model should be mutable so that when and like globally shared, right? So that you had like one model of all the type information in the project. And so if I go and change that declaration, it mutates the model, which changes how it looks everywhere to all projects. So you get kind of some of that updating for free. Now, the challenge with that is, of course, how we store the model is not currently amenable to that. It would need to be like separated from the LSTs a little bit. There need to be a level of indirection, particularly since all the LSTs are not necessarily in memory at the same time. So you can't go and modify stuff on an object that isn't even there yet. Anyway, something I've been thinking about in terms of just improving the capabilities of the framework and making recipes more powerful. So I guess that's at least thematically somewhat aligned with data flow and taint tracking, since we're talking about how to make the refactoring framework more powerful.
Yeah, I think we've spoken before about trying to pull apart that indeed type information from the LST elements, but it's just I think quite quickly we'll run into like OpenRewrite version 9, which we're not yet gathering suggestions for, but it's definitely something on the list there.
There's definitely some breaking changes in what I just discussed. There's definitely some things that that might be one-way transitions in terms of wouldn't want to carelessly impose that on people. How long have we been on OpenRewrite version 8 now? Like it's
a good year and a half, I think.
That sounds right. Because we've been like, after we got to 8, we're like, well, let's try not to mess with our API too much so we can have something pretty stable to build upon. So we're up to minor version 68. But I am just 5 days ago. Thanks for releasing that,
and of
Tim.
course we release every 2 weeks, so you should be able to like divide by 2 and or multiply. But I think this one,
Hey, here we go. June 1st, 2023. 4,700. It was a good approximation, though. If you got an approximation that's only off by a week, you are doing all right. Wow, 4,000 commits since then. We just hit the big 10,000 commit milestone. Yeah, wow, we're already at 14 commits over it. I was a little jealous that someone else got commit 10,000. I'd kind of had I think it was it was Greg. I think one of these was like commit 10,000. So congrats to Greg for snagging a round number. It's a completely meaningless non-achievement, but I'm also very envious of it. It's funny how that works. Yeah. Kevin remembers Rewrite 8 because that was a big challenge for all of our stuff. Had to change because like the big feature change there was being able to stream being able to stream LSTs off disk into memory. Before that, there was no way for you to have an OpenRewrite recipe that operated on an LST that wouldn't fit into memory. So we had like a hard kind of, not hard, but there was a limit on how big of a repository you could address. And that wasn't going to work for the big mono repos. So that's where scanning recipe came from.
And I think Kevin subtly corrected me as well, whereas, was it 2003 in June 1st? Because then I was off by a year and a month and a week.
Oh, yeah.
Wait. That is, time flies.
8.0. Yeah, June 1st. 2023, so
it's 2.5 years even. Okay.
Not 2003, 2023.
2023.
Yeah, I haven't been working here for 20 some years.
But yeah.
Oh, good stuff. So yeah, you were messing around a little bit in the data flow and taint tracking stuff earlier, Tim. And I think in preparation for this stream, you said you found a bug.
Yep. It's like I can't help myself, so I try to find like what corner cases can I think of that haven't been done. And of course, the first thing you do is you run this recipe at scale against our own repositories. And I was
Yeah.
finding surprisingly many hits against constructors.
Mm-hmm.
And they, of course, assign fields. And at that point, you think, well, that's probably an issue with our detection. And then
Mm-hmm.
you
Mm-hmm.
write a test corresponding to that, and indeed, our detection is off. So if you these two
Ah.
tests, if you don't change anything, they both fail. And this is because we're checking assignments using identifiers, but we're not taking into account the owner of the identifier. So if that is
Ah.
wider than the current scope, then yeah, that's just not going to work well.
Yeah,
And
that
then
makes
yeah,
sense. And you can
and then of
also,
course
yeah,
yeah.
you need to do that to tell the difference between an identifier's name has been shadowed from a field. Because you could obviously have a
Hmm.
field named foo and a local variable named foo to be differentiated, with
Yep.
this. Uh, so let's see. So maybe we could just review this right now. Does this
Yeah.
does this fix work? You've got this marked as a draft. Is
It's a draft because I took like the typical fix we would do, not
uh-huh.
looking into like the flow analysis that we did, but really
I
operating
see.
at the level of the visitor. But
I
I
see.
already know and called out this should probably go into that store analysis.
Yeah, yeah. Good call. Good call. All right. Well, we'll look into this after the stream. See about getting this merged. And
Hmm.
yeah, the more we use this functionality, the better it will get. The only way to get good working software is to use partially working software and then incrementally improve the deficits until you get there.
Hmm.
Good stuff, Tim. Good
Good.
stuff. Let's see. Do you think there's any other recipes in here we should take a look at? I guess we looked at data flow. Maybe let's look at a taint tracking one because that could be very relevant to security
Hmm.
scenarios. Maybe what's array access taint test look like? So if we pop over in here, yeah. So it looks like this guy is for finding. Yeah. So this is helping to find command injection that passes through an array, so that you could know that maybe the entire array, or maybe even individual cells or parts of the array, were tainted with something, to point out that this is directly executing code that came from a program parameter, classic code injection or command injection uh,
Hmm.
setup. So yeah, let's take a look at how this guy works. So if we go look at find command injection, we have a simple taint tracking recipe, right? Unlike the last one we looked at, this isn't just extending recipe. This is extending simple taint tracking recipe. And this has a taint flow spec, which defines a list of sources and a list of sinks. And often with taint flow, you're talking about something being, well, tainted, right? You have a particular variable, you have a particular source of user data, you have some configuration or like a network request, something coming in that's a little bit suspect. And it might be a problem if that suspected or tainted information makes its way from where it comes into the system into a particular place. So in this case, we're looking for, kind of places where different kinds of network requests or user data, or not user data, but like user configurable stuff, coming from the environment variables or system properties, or reading from the console or reading from a file, might make its way from any of those places into something that starts a new process, or starts executing a new command. So we're interested in, when does stuff from these sources flow into these sinks, and then is there anything in the middle that might remove that taint, anything that might sanitize away that taint, where you could say, okay, yeah, user data went into the escape avoid SQL injection function before it went into the SQL query, kind of thing. So you have sources of taint, sanitizers that take taint away, and sinks that if a taint reaches it, it's a problem. So this taint flow spec has you implement these match source, match sink, and match taint removers methods where you can say, look through, like in the source, we could say, is it any of these? Is it any of these methods? Then, if so, we found a taint source. And similarly, in the sink, it's going to look through, hey, are any of these, is this a method that is one of the sink methods? And if it is, do some stuff specific to those individual methods to try and figure out if it's a problem or not for this scenario. And the taint flow remover is just looking for one of those blocking methods to appear between the source of the taint and the sink that the taint goes into in order to remove that taint. And handling this for a couple different kinds of things. Handling a method reference versus a direct method invocation. Some of the syntactic variations on invoking on one of these guys. But yeah, like this guy is, I think, pretty simple to understand, like simpler than the other one. So let's look at this. Find command injection test. Yeah, so we see some examples of what this is trying to detect, places where you're loading up a parameter from a network request and then directly executing it. This would be a bad idea for most servers. You wouldn't want your server accepting a request that it could then execute directly. At least not if you're not trying to host a public Bitcoin farm and virus hosting server. You probably don't want to do this kind of thing. And so some of the trick that this taint flow analysis and source tracking helps you deal with is, these examples are pretty basic, right? Like you could find this in a recipe that just iterated over a list of statements and looked for, get parameter to be followed by new process builder. But the taint flow and data tracking helps you to keep track of all the things that kind of happen in the middle, whether there's a bunch of control flow, if statements, function calls, whether stuff gets assigned to other variables and then reassigned and then finally makes its way in. So kind of handling all the permutations for you of how data could flow between a source of that data and a sink for that data. So whenever you're kind of like thinking, I need to know, stuff that happens at point A and makes its way to point B by any means, taint tracking can help you to answer that question. Yeah, and we see some things, some complexities here already coming in these tests of things like, okay, well, we loaded up into this user input command or variable, but some processing happened on that before it made its way to the sink. That should still be counted as a command injection, right? Should notice that this command, was tainted because something tainted went into it. So taint tends to propagate in that way.
And of course, as much as with the dead stores, of course, these examples, they're very simple. But if you think about as the scope of your body, of your method body grows, and even having to span across different methods, this gets larger and larger and more difficult to see. And if you have different control flows going left and right, then maybe there's a couple of paths that are not correctly sanitized.
Hi back to you as well, bad S8J. Glad to have you. Yeah, totally. And yeah, here we see an example of how sanitization works, of how this is, asserting that that this is not an example of a problem because there is this escape shell arg in the middle, which is going to make this okay. But it looks like replacing. It looks like this is. I mean, it's not super important what this escape shell arg actually does, but it looks like it removes from the beginning of the string anything followed by underscores, dashes.
It's within those blocks, so it's a negation. So anything that's not one of those gets removed. So if you
yes, you're right. You're right. You're
If you
right.
use a
This would be,
semicolon,
gotta remember my
yeah,
regular expressions. This would be
yeah,
match only stuff at the beginning. This is match all characters except for these characters. So this is saying allow only
yeah.
alphanumerics dash underscore period.
And of course, those red curly braces are because you shouldn't escape those things within the dot. I think you need not escape.
Yeah, I don't think
Dash,
you
I
need to
think you
escape.
need.
No, yeah, I
No,
don't think
no, you
for
do.
within a character class a dash is, well, it definitely has a
Well, the
meaning
other one you
here
need
in
them
terms of
there.
establishing a
Yeah.
range.
Yeah. Oh well.
I'm a little curious now. Is this escape needed?
So much of programming is just trying to execute it in your head and then trying to have arguments with yourself whether you're right or not. And,
Yeah,
yeah.
yeah, absolutely. And then, going and testing it at some point. But again, this what the escape method actually does isn't that important to the find command injection because that recipe is just written to trust that whatever escape shell arg does is fine. Even if we just change this to arg and that didn't actually do any
Yeah.
sanitizing, the recipe would be like, well, that's on my list of sanitizing functions, so like it must be okay, right? Us not remembering the details of regular expressions is not doesn't isn't actually relevant to data flow or taint tracking, which is of course a reminder to
Hmm.
d- double check your assumptions, right? The sanitizing method was called, but did anyone actually implement the sanitizing method? There's no substitute for rigor. All right. Well, I feel like we've given a decent little tour of that subject to start
Hmm.
with. Anything else you think we should talk about in tape tracking data flow analysis at the moment, Tim?
I think I think more the takeaway here is that if you have these kind of use cases, and this can be like we've seen here, user input going into like commands or maybe SQL injection, just
Hmm.
know that we have these capabilities to work these out. And then I think this also applies to some of the problems we've solved previously in different ways. So if you have a feature flag and you want to be sure that that constant that's being used and it's being set to the feature key that you're looking for, that it would be really helpful to be able to detect all of the different ways in which you might confuse folks otherwise, but still be able to work this out with a recipe.
Yeah, yeah, absolutely, absolutely. Um, yeah, good point, Tim. Good point. Yeah, and so this is an example of I'm curious what other we kind of mentioned before that the LST is everything that's printable, everything that appears within the text of the code. I'm curious about any thoughts you guys might have as as open rewrite users or recipe authors about semantic analysis capabilities or semantic changes. What do you think an interface that was more oriented around changing the meaning of a program rather than changing the syntax of a program? I find that a lot of the recipes we write are are intended not to change things, or rather, not to change the behavior of a program. We want to improve the code quality while keeping the behavior of the change. We want to get to the new version of Spring Boot while keeping the behavior the same. I wonder if we look through all the recipes we have, I bet like 90+% of them are trying not to change the meaning of code. And so I wonder just about scenarios where that might not be the case, where you might be doing a change or refactor that did intend to change the meaning or behavior of the code. Well, now I'm just kind of getting into speculation. But if you have a scenario like that, come into the comment section or into our community Slack and let me know what it is. I'm always interested to hear about new ways that
Hmm.
people are using or thinking about using OpenRewrite and yeah, this kind of stuff in general.
Yeah, yeah, absolutely.
All
So
right.
then, yeah, with that, we want to thank you all for joining us today. And we're going to look
Yeah.
ahead at next week. I'll be out, but Sam will be in, and we're going to be talking about the Modern Adoption Playbook, about
All
how you
right.
can make recipe runs part of maybe like your day to day, not come to us every half a year when there's a new Java version or a new Spring version, but really look at ways to drive that home. So going just beyond those upgrades to other ways to be using this technology. So
Yeah,
hope
I look
to see
forward
you
to
all
it.
then. Yeah, and then with that, see you, and from my side, see you in the new year. Cheers.
Yeah, see you in the new year. Bye, guys.
Bye bye.